Yes, everything's gonna fit nicely. And if it doesn't fit, I'll make it fit. Pretty much like I just made it fit in your mother last night, Trebek.
That's it, Connery, you're on a timeout.
Greetings, the Astro 30 here. Welcome to part 6, I believe we're up to now, of this Class D amplifier build. In today's video, I'm going to be working mainly on laying out the chassis, that is, working out where stuff goes and drilling the holes to mount things. And as by the title of this video, this is hardware number 2. However, I'm not going to be looking solely at the hardware in this video. I will be looking at solving the voltage issue here with these two resistors not dropping enough current into this regulator here to allow it to run on 42 volt DC coming in off of the 30 volt secondary. And I've got two solutions to that. One is just muck around with resistor values until it works, even though I've done the theory and the math behind what these should be, but in the real world it doesn't work that way. Who knows? That's one way. Or there is another solution where I can just wire a 20 volt 1 watt Xeno diode from the end of this resistor network here and ground, with the cathode pointing at the end of the resistor network, which is what connects to the regulator as this end of the resistors. However, that means I'd have to solder the Xeno diode on the underside of the PCB. No real great big deal. I mean, it has been done before. There's where it comes in as an input on the regulator there, that trace there in the middle, and the ground plane is just above it. So yeah, I could solder the Xeno across that. However, that's one route that I don't really want to take, but it is what it is. So what I'm going to be doing is I'm going to be wiring up at least the secondary of this transformer, the 15015, to the low side of the power supply. So I've got the 30 volt AC output over here, which I can then play around with that. As we can see, the front panel is now back off. This is just hanging loose. I've taken the headphone amplifier and sub-bass processor unit out. When we look down here, we've got something which looks like a mirror, but it's not a mirror. This is a piece of 1mm thick acrylic, which all I've done is I have liquid nailed directly to the aluminium sheet here. And this is the stuff here. As you can see, it is actually semi-translucent. And of course, up against the aluminium, it just looks like a sheet of glass. Now, the reason why this is a scrap bit now is I tried cutting with a pair of scissors this stuff, and yeah, it's very brittle. It just sort of does that and breaks, so that was a wasted bit. Anyhow, that's going to provide me some insulation. Now, I worked out that if I orient the power amplifiers, and I still have yet to build that second module, I'm putting it off and putting it off. If I orient it this way around, so the heatsink's facing towards the left-hand edge of the case, that allows me to overlap, and I'll just grab the volume board here, which is going to be remade, but if I put that in where it goes, we can see that it will clear the power amplifier board just nicely if that was where it was going to be sitting, which it is. However, if I mounted it the other way around, like 180 degrees, that volume board will be coming into contact with this capacitor and these transistors here. So that became a little bit of a prick. So I thought, well, I'll turn it around. And that just means it puts the input all the way over here to the power amp, which is okay and fine. That's keeping the sensitive side of the circuit well away from the power side. So that will still work. And with this sitting 20mm from the front edge of this aluminium, that gives me plenty of clearance between here and the front board here. And when two boards are laid out, you can probably sort of see that there's just enough space to fit two there. And I've got all of about probably 1 millimeter of movement between the back of this board and the heatsink. So, keeping in mind that's where the power amps are going to go, everything should fit, because otherwise I was going to have to like either turn one of the boards around and mount the input sockets like in the middle of the case somewhere, which would have looked fucking stupid. Now all I've got to do is work out my measurements of where things are going to be placed, like where they sit now, then work out where the hole centers are, center punch them, drill them. It's a fairly shit day out there today, and I've got to go outside to do the drilling. Nice. And then I can then go about mounting stuff. And I'll drill the holes for the second module and put the standoffs in the holes ready to accept the new PCB. But obviously I don't have the PCB yet. Here it is over here. I've already opened the kit, and I took out the circuit board to use as a template basically to lay it against the next to the other one to see the clearance between that and the input selector. And I'll also need to either file or sand the edge of this a bit so it's flush with the aluminium. So first what I'm going to do is I'm going to take a measuring tape and measure my rough placements of things and write that down, and then I'll take the chassis back out of the case. I've already removed one screw down here. That was for a particular reason. Can't remember what the reason was now. Oh yeah, to see the clearance of this between that and the circuit board, but the screw was in the way because it was a longer piece. So I took the screw out. Take the chassis out, mark it all out, center punch it, and drill it. So yeah, let's get started. And so about 20 minutes later, I've done some measurements and worked it all out of placement of things. Now it looks complicated as hell with all these measurements on here, but it was like with these boards, for instance, it's 10 millimeters in, it's not to scale. It was 10 millimeters in. The total length from that side edge of the aluminium here to the first hole center over here was 175 millimeters, and the whole distance between the two hole centers is 160, and conversely the two hole centers in the vertical direction is 103. So it's 5 millimeters in from each edge for the start of the hole centers and 4 millimeters in, hence there's 24 here and 20 to the edge of the circuit board. So that means there's 4 between here and this edge, 4 between here and that edge, or that hole, so that makes it 8. I might jiggle that, I may not, don't know yet. But yeah, that's what I did. I just basically measured where the edges of the board started from one particular side of the metal there, and then measured the hole centers on the board itself, and then worked out where they were. So now it's just a matter of marking it all out onto the aluminium, and that's supposed to be a terminal block. I just drew that in there so I knew where it was going to be placed, roughly 20 in and 80 down. And that thing marked with a star is, let's see if you can guess what it is. That's right, the star earth point. So that's going to sit at 95 in by 235 down. So the next step is to mark it out onto the aluminium. Now the thing with using a center punch, and I'll just use this piece of scrap plastic as an example, is these automatically have a hammer action. So when you push it in, it does that and marks your hole. And you'll be probably doing it a couple of times to get a nice dent. Now the thing with these is, with metal sitting on a semi-hollow wooden surface, it's going to be loud when you're in close proximity to it. So it's always advisable with these, or even if you just got the normal punch where you hit with a hammer, wear ear protection, because it will start making your hearing ring, so to speak. So just keep that in mind when using tools like this. Anyhow, I'm going to get on, mark it out, and yeah, we'll come back when I've started doing something. Okay, I didn't even realise the camera was set to manual everything, but anyway, that's good because I can alter the gain of the iris quite significantly. So what we're looking at now is the panel all marked out, albeit some of these hole centers may be slightly off. So what I'll do is, in the end, I will probably drill these holes up to 4mm to allow, you know, 0.5 millimeter leeway each way. It's only the sub chassis or the chassis itself. It's not terribly important if holes are off, as long as things mount and it works. I also forgot to put in a earth point here for the AC, so I put one there. Had to move a few things around over here because I got my measurements messed up somehow. It happens. So what I need to do now is I'm going to drill my chassis, and yeah, so we'll come back after I've done that. So I'm going to do the drilling inside. I've got a drop sheet on the floor to catch any crap that flies off. Might want to move some circuit boards and stuff that are important out of the way so they don't get covered in crap. I'm going to start at 2.5mm for all the holes and work my way up from there. And of course, the drill press deck is not deep enough to drill some of the holes. So I have to do it by hand with a hand drill. But I will. Alright, that's my chassis all drilled with the holes drilled up to the sizes that I need. And I've done a rough test fit of all the boards. They do fit, so I shouldn't need to do any manual massaging of the holes. That's why it helps to measure. So the only thing I have to do now is sand the edge of this a little bit more flat. So I'm going to find out what I did with my sanding block. Yeah, that's a bit better. So now the next thing to do would be to mount it back into the case and then start mounting some hardware and see what we get. Okay, this should be the last time I need to take this out, so I can do him up now and tighten it. I'm just going to go from corner to corner and then finish it off. So after I've done this, next I might mount the two toroidal transformers, and hopefully this bolt that I've got lying around is long enough, because if not I'm going to look like an idiot and I'm going to have to go out to the hardware store and buy a longer one. So hopefully that doesn't happen. Now the secondaries for the most part have to go towards the bridge rectifier down over here, so I might make the best of both worlds and just put them so the wires come out roughly direct center bottom. And because the two center taps have to go to the power supply down here somewhere, so I'm going to put it about there somewhere for the wires coming out. Now, pass my bolt up through the hole. If I can find the hole. Yep, get the second rubber. Now it looks like it's about 5mm too fucking short. Okay, so that won't be mounted right now, so I'm going to have to go out, buy a 60mm long. I think this is 60 anyway, aren't they? Yeah, these are about 60mm long. I need to get something like 70 or 80mm long. I'll probably get a proper hex bolt and nut for it anyway. So I'll mount my second transformer. Now there's a flat here and a recess on this side, so the nut goes in the recess. So I need the rubber condom, well not condom but rubber mount for that. That goes there, transformer goes on top, and I'm going to leave the wires coming out somewhere towards the centre there. So I'll just get my hardware pack here. Now we have one normal flat washer which I'm going to put on the end of the bolt like that before it passes up through the chassis and scratch the shit out the size of the case. Pass the bolt up through the hole, and there's a spring washer here which will go on the top plus the nut, and this is going to be awfully awkward to do. Hopefully I've got a socket that'll fit that. I reckon that's about 12 mil. So I'm going to go get a socket and a wrench and we'll do that up. Okay, I lied, it's a 10 mil. So, whatever. I don't have a 1/4 inch extension for this ratchet, so I'll just have to do the best I can. There we go. Now, let's make sure that that is central. Thing is, you don't have to over tighten these, just so that they're, you know, snug like that. And that's why I use 1/4 inch tools for things like that, because you won't run the risk of over tightening things. So that's mounted for the most part. I might start with the speaker protector. Now I'll have, it's really much of a muchness here which way around to put it. Whether I put it that way around so the connections all face the power amp, except for the protector, of course. No, I might leave it that way around. If I can always change it later. So I need some screws. And a short time later, everything is mounted in, and everything just clears everything just nicely. This blank power amp PCB was just put in here for reference to make sure they butted up together nicely, because they are actually sitting butted together. I've mounted the one that's been built here on purpose, just so I could get an idea of how much clearance I had from, well, the edge of the PCB and the back panel and the heatsink and the back panel. And there is just enough clearance for this input selector to mount. I've got all of about probably 2 millimeters, because the back panel doesn't mount flush with the lip edge here, it mounts on the top of it, so I've still got an extra like 1 mil there to start with. So that will just fit nicely and clear that heatsink, and that was what I was going for. So everything's mounted now but this large 300 VA transformer, because I need to go and get a bolt. But for the most part it's all assembled in the case now, so at least they've got a home, they're not just floating around my room somewhere. I should have enough clearance now to get the volume control board in and out, the tone amp board in and out, the headphone socket board in and out, without having to remove the power supply or anything. So I can get that just in there nicely, and when I rebuild this one, that'll go in just nicely without having to remove anything else, which is also the idea here. So now the next thing to do is to have a bit of a break, and then I will probably look at hooking up the 15 volt transformer anyway, or 15015, to the terminal block, get some AC going into it, test the 15 volt side here and try and get this input selector over here to work at 30 volts AC or 42 volt DC. So what I might do first is have a smoke, and then I might go out back to Kingston, which I'm not impressed about, and go get a longer bolt. Alright, we'll continue this shortly. Just one thing before I go and get the bolt is, with this bridge rectifier, they've only marked the positive and one AC connection on one face of the device only. And there's no chamfer on one side to denote where the positive lead is. However, they've got this at 90 degrees to the rest of the pins. So if we look at our standard 4-wave bridge rectifier circuit, we've got two anodes connected together forming the negative rail, and we've got two cathodes together forming the positive rail, and each of the two anodes and cathodes respectively of the two sets of diodes are joined together to form each AC pole. So therefore, theoretically, now because our positive's down here, so we'll assume that that's a chamfer, and most bridge rectifiers all follow the same pin layout, so I'm pretty sure that I know where the AC connections are. So we've got the positive here, so that comes from one cathode of the diode string and the other cathode of the diode string. So these two cathodes form the positive. So therefore this anode here would be connected to this pin here, which is the other AC connection. Conversely, we've got an AC connection over here which is connected to our anode of this positive string, which would also be connected to a cathode of one of our negative diodes, and the negative pin will be here, and the other anode from over here would be connected to there to form the negative. So we should say that AC is here and negative is there. So if we do a diode test on each of these pins, we should be able to figure out that yeah, we've got an anode, a cathode there, an anode, cathode there, a cathode anode there, and a cathode anode there. So we will know that this is going to be negative and that's going to be AC. Now I can confirm that later, but I just wanted to point that out because that particular bridge rectifier that I've used does not denote where negative and the other AC connection is. But for all intents and purposes, that's how it should be wired. But when I come to actually wire up the transformer to that particular point, I'll go through and measure that and revisit this later and see if I was right. Okay, and a short time later, I'm back with some 75mm long bolts, the same diameter as the ones that this is. This is 60mm, that's 75. 1/4 inch, I've got some 1/4 inch, can't remember what they are now, spring washers, it's written and I can't even read. Got a 1/4 inch flat washer and a 1/4 inch diameter by 7/16 head nut to all suit. And that cost me around about $8 for all that. I mean, I need one bolt, one washer, one flat washer and one nut. That would probably cost me about $1, but it is what it is. So now I can mount my transformer. Start with my neoprene washer. Make sure there's no metal shavings on it. Move those wires out of the way. Place it over my hole, get my bolt, pass that up, put the flat washer on the bolt first, then pass it up through the hole, and so grab my transformer, put that in there. I've got these wires in the way, move them out the way, stay out the way. Okay, second neoprene washer. And I think that's plenty long enough. The mounting cup, spring washer, and finally the 1/4 inch nut. Like a glove. Okay, so I want to make sure that that's all centered properly, which it is. And the wires are roughly where I need them to be. So now I can go about doing up the nut, so I'll put my screwdriver on the bottom here to hold the screw and turn the nut. And again, this does not have to be overly tight, it just has to be tight enough to hold it down and stop it from spinning around. And also when doing up the nut, be careful of these wires sticking out that you don't accidentally nick them and damage the insulation. So I'm going to say that's tight enough and it doesn't move, that's the main thing. Okay, so the next thing I need to dick around with is wire up the 15 volt transformer to up here where it goes, and mount these AC wires to the terminal block where they're going to be going. I've got going to have the active coming in this left hand side, the other side goes out to the switch returns, comes back to the center, the active of the transformers come out at this center point here, and then there's just neutral carry through from the power to the two transformers. Now, I'm not going to wire up the large toroidal transformer because I do not want, 35, 70 odd volts hanging around up here with the leads just flapping around in the breeze. So, excuse me, I need to just wire up these only to the plug wherever I put my fly lead, it's around somewhere, and hook these up to the connector here, and then measure the voltage out here at the positive negative 15 volt and see what happens. So I'll get doing that now. Okay, I've got everything hooked up now. I've just got this on the voltage scale and I'm going to plug it in now after I turn my alarm off and measure the 30 volt DC rail coming out. And I've got 75 ohms across the primary of this transformer, so that's perfectly fine, so nothing should go off with a bang. This light function on the multimeter doesn't stay on very long. Anyhow, plug it in. And we have 30.29 volt. Perfect. So let's unplug that for now. Okay, so I'm now hooked up to the 30 volt AC side. And we're going to measure what the AC voltage coming out of that 30 volt connector is. So I'll plug him back in again. We've got around about 32 volt AC. Okay, and that instantly goes out when you unplug it. And I've got a bunch of 1 watt resistors ranging from 560 ohm I think it is up to 4K7. So what I'm going to do is I'm going to dick around with the resistor here that's on this board, but what I'm going to do first is I'm going to confirm the problem. So I'm going to, confirm that it doesn't work in the current configuration. Okay, so I've got the AC side hooked up to the board and I've got the connector for the switch hooked back up. So what I'll do is I'll plug it in and we'll just see if there's any light or life on the front panel. It was for an instant and then it went out. So that means that the voltage is too high. So, turn my soldering iron on, but what I'll do is first I'll just lift one end of one of these 470 ohm resistors here and see if it'll work with just 470 ohm in there, and work our way up from there. Okay, so I've got one of the 470 ohm resistors just hanging out there. So now I will plug it back in and we'll have a look to see if that made a difference. I don't think it will. I mean, this is probably the most non-technical way to do something. No. Didn't make any difference. Okay, so what I need to do now is lift the end of the other resistor so that one's hanging up one way, one's hanging up the other way. Just so I've got places to connect fly leads to. And then I'll just use a piece of breadboard with the resistors shoved in there. So I know two 1Ks in parallel are not going to work. So let's start with, well, I'm going to do it with just one resistor to start with, like one 1K, and work my way up and see which works best. Okay, alright, got my 1K hooked in there now, so I will plug it in and we'll see what happens. Again, this is a very non-technical way of doing things. Huh, what do you know, that worked. can't hear the secondary relay going in, so that wasn't getting very hot. So I might up that to 4K7 just out of the box and see what we get. Okay, 4K7 is connected. Plug it in. Actually, now there might be a bit too much of a drop there. Okay, let's try 2K7. Go 2K7 in. Let's see what happens. Yeah, it doesn't like it. When that secondary relay tries to engage, it just refuses to work properly. Okay, so I'm going to leave the 2K7 in there, and I'm going to connect my Xeno diode now between the white wire here, which is the output, and the other end to a convenient 0 point. Alright, the Xeno diode is connected, albeit it's all over the place, but that's a 20 volt 1 watt Xeno with a 2K7 1 watt resistor. I've got the, well, I did have the anode of the diode connected to the 0 reference point, and the cathode is connected at the end of the resistor network to the rest of the circuit. So, alright, let's see what happens. Still dropping down in voltage. Okay. So maybe that resistor is too high, so I might go back to a 1K. Okay. The other relay is still not engaging. Okay, 1K is still too high. So I might stick two 1Ks in parallel and see what happens. Okay, so I've now got two 1Ks in parallel with each other, and the Xeno diode is still connected, and for all intents and purposes that's 500 ohm. So well, the interesting thing is the light's coming on, but the relay is not for the tape monitor, and I don't know why. Well, wouldn't you know it, 470 ohm 5 watt resistor seems to do the job. I'll see if I've got a 390 in 5 watt just to make it a little bit more better, but now everything is functioning. Is the Xeno needed? That is the question. So we unplug, I disconnect the end of the Xeno, and then replug it in. Yes, it is. Okay, so I know that the Xeno is required, and it probably could go down to a 15 volt for all it matters, but I'll leave it at 20 volt, and I'll see if I've got a smaller value 5 watt resistor. And well, for all intents and purposes, I reckon a 1 watt device will suffice. So let me just play around with that for a sec. Okay, so what I've decided on is two 820 ohm resistors in parallel, which gives us roughly 410, because remember 470 was just barely working, with the 20 volt Xeno across it. So that means I do have to put the Xeno diode across the bottom of the circuit board, but it is what it is. And I've seen plenty of things manufactured that way in the past, and they're getting mildly warm but not overly hot. As for the Xeno, not even getting hot, so that's fine. So I now know I've fixed the issue with the input selector. I'll just take it out of tape monitor mode. Every relay is engaging now. What I want to know is what's the actual voltage drop across that Xeno. It should be close to 20 volt DC. And according to that, we're looking at 15.9 volts, which is, yeah, okay, it's good enough. I'll turn the tape monitor switch on. Yeah, and we're dropping down to 13 volt. It's barely enough for the regulator to work. So 820 might be a little bit too high. Okay, 120 ohm is connected. Yeah, got close to 17 volt. 15. I think I might go with 120 ohms. So 220 ohms would equal 110 ohms, which should be enough to work with the Zenos just nicely. So I'll put my two 220s in parallel and we'll have a look. Okay, so now what I've got is a 220 and a 390 in parallel because I don't have two 220s. That gives me roughly 140 ohm, which is close to the 120 that I want. So I'll plug him in just to confirm. And we've got 17 volts there. Everything seems to be working. Yep. Drops down to 15. So I'm going to go with that, and yeah, we'll say that that's what our values are going to be, plus that 20 volt Zener. 24 probably would have been better, and I would have had a slightly higher DC voltage there, but for all intents and purposes that's just enough for the regulator to operate even with all three relays connected at the same time. And we're not getting much of a drop in voltage when I change inputs. So, and when the power LED is connected to that circuit, I'm not sure how much further it's going to drop down, but it shouldn't drop down that far because that LED probably draws all of about 2 mA. So anyway, I'll get to soldering the new parts onto the PCB and then do a final test. So there's my little concoction there. I've got the Xeno diode with a couple of pieces of heat shrink either side on either pin there to just make sure that it's not going to come into contact with anything accidentally. And it's raised up off the bottom of the PCB about 2 millimeters either side, and then just soldered to the relevant pads, well, relevant traces. This one being the positive feed to the regulator, which is where the cathode is connected to, and this side being the ground plane. Got the 220 and the 390 ohm resistor installed in place of the two 470s that were there before. Now, because they're an imbalanced value, this is where resistors in parallel becomes a little bit of a bastard. The lower value resistor is going to take most of the current rather than sharing it equally. So this resistor is going to get hotter than this one. They will still sort of share the current equally to a point, but you're going to find it's going to try and go through the path of least resistance, so it's going to go through the 220 ohm rather than the 390. So the 220 is going to get hotter than the 390 is basically what I'm trying to say. Okay, that's all hooked back up to the AC supply, so I'll just turn him on and confirm that it still works. Apparently. Both one of the source lights and the tape monitor light are on. Turn that off. I can hear it's clicking in and out. But those resistors are only going to get really hot when it starts drawing 150 mA, and that's when the muting relay is turned on, the source relay, one of these is turned on, and the tape monitor at the same time. The likelihood of that being true in practice is not very often. So currently, with those two resistors on their own, I can feel they're getting slightly warm to the touch. And they are fairly hot, yes, but they're not exceeding what I would consider dangerous. Now, yeah, they are fairly hot to the touch, so got to keep that in mind. The regulator's nice and cold. So, yeah, that is fairly hot, but it should be right. I mean, I was thinking about trying to stick a 5 watt resistor in there, but it wouldn't quite fit in there properly. It kept on banging up against these connectors, no matter how I configured it. So for now I'm just going to leave it like that. And I'll leave it running for a while, and I think we'll conclude this video here, because it's getting pretty late in the day and I'm pretty spent at the moment. So yeah, I'm going to have a quick break and have a smoke, have a Kit Kat, have a wank, all that sort of shit, and yeah, we'll come back and see if the circuit's still working. And about 5 minutes later, yeah, it's still functioning, and just for shits and gigs, I hooked up the LED from the power switch I'm going to use to the LED port, just to make it light up. These resistors are getting fairly hot. I am kind of concerned about that. I might have to rethink that. But for the main part, it is working. I fixed that problem. The hardware I wanted to mount today is mounted, so I can now move on to something else. The input selector I will tinker with a little bit later. I'll see if I can find online some 2 watt resistors instead of 1 watts of about, what did I want, 120, so yeah, 240, 260, something like that. And I've also ordered from China a large 38mm black CNC lathe knob to replace the small little 28mm one that I've got, or 29, whatever it is. So it's going to have a nice large knob, so that makes me happy. So I'm going to leave this video here, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 belching and saying, see you later, have a great day.